Good morning to one and all. Welcome to the 22nd International Conference on Hybrid Intelligence System. Paper title is Outlier Detection from Mixed Attribute Space using Hybrid Model. Paper ID is 120. So myself, Lingam Sunita, I am the corresponding author for this title. So I'm working as a professor in the Department of CSE, Bartman Engineering College, College of Engineering, Hyderabad. And co-authors are M. Balrasu, Dr. M. Balraju, Shanti Makka, and Shravya Ramasahayam. So contents of the presentation includes introduction, literature survey, problem statement, objectives, what is IQR, hybrid IQR, algorithm, experiment result, conclusion, future scope. So what is outlier? What is outlier? So outlier is a object which is so much far deviate observation from the other one. So many of the fields are having important than the outliers are important than the normal data. So why the outlier detection is important? In a practical or real-time data sets, outliers always existing by the different reasons, either instrument failure or formatting errors and non-representative samples. So outliers can include the summary of the statistics, and presentation of outliers leads to the classifier regression can result in poor fit and lower predictive model performance. So algorithms like SVM and are more sensitive to the outliers. So if you're including the training data set, it will gives a low performance. So there are three types of outliers: global and conceptual and collective outliers. Coming to the application, there are various applications of the outliers: fraud detection and detecting the measurement errors. Next, applications in the medical field. So we can find the symptoms, and unusual symptoms will give the abnormality of the test. So some problem with the patient. In the health, it is some problem, it is indication of it. And another one is monitoring, environmental monitoring, natural calamities like earthquake, cyclone can be detected by finding unusual changes in the weather data patterns in rainfall. Next, literature survey. There are some papers our most relevant papers are tablet formatted here I have prescribed. So many of the existing algorithms are either suitable for numerical and only for categorical. Some are having the mixed attributes porting, but the threshold problem is there in the existing models. So here in this model, the last one is proposed existing model, which I compared the results with AOMED. This model given by the Mahmoud Bhogest in the 2016. So in this work framework, he is considered as a 10% objects are considered as outliers fixed. So motivation for this work is many of the existing do not handle the mixed attributes. Many existing works domain expert decide will domain expert needed the domain expert and to decide the parameters of outliers. We aim at handling the mixed attribute data set and minimal or no user interaction. The problem statement design and outlier detection algorithm for data sets with a mixture of categorical and numerical input variables. So objective is to design a algorithm which is a probability based algorithm and statistical measures based the hybrid model, interquartile range, IQR, hybrid intercutter range is the algorithm, the proposed algorithm, and the results are compared with the existing algorithm AOMDD. So what is interquartile range? It is calculated by IQR is used to find the in a data set, we can divide into 4 parts given Q2, Q3. Then IQR is calculated by Q3 minus Q1, and the lower bound is calculated by Q1 minus 1.5 IQR, and Q3 plus 1.5 into R is the upper bound. So this example is given here. The 50 is a outlier in this. Lower boundary is -2 and upper bound is 10. Below -2, nothing is there. Above 10, 50 is outlier in this. This is called box plotting. So fences will be decided, the boundaries will be decided by the IQR formula. So coming to our proposed algorithm here, it is used. Basically, IQR is univariate. It will applicable at single attribute, only numerical. But now I am taking each and every object we are taking the data set, having the missing values, compute an anomaly score for each and every data set. So after that, we are applying the IQR. Use anomaly score to identify the outliers in the data files. So IQR is used for on total anomaly. This workflow in this one. So totally given data set is 2 attributes are there. After handling, we can assign the anomaly score for each and every attribute, and we can decide either outlier or inlier. So the two formulas used in the calculation of anomaly score. For numerical attributes, I am calculating the mean and standard deviation, and each and every attribute value is subtracted from the mean and divided by the standard deviation. We can assign the score, and summation of the score gives an objective score. For categorical, I use a probability score, probability of P I by Dij. Ith object and jth is instance. For example, this is a conditional probability I use to calculate this one. Total anomaly score is calculated summation of 1 to I Dij. Total score, we get each and every object is assigned the total anomaly score. So now we can apply the IQR model here. So now I got a total anomaly score. Now I can apply the IQR in the total anomaly score. I will divide the total score, the data sets into this sorted than this one, then IQR divide, and these are conditions I will use. Total anomaly score is greater than the Q3 plus 1.5 IQR, or TS of I is less than Q1 minus 1.5 R. Then the target is assigned as an outlier, else it is normal object. These are conditions I am using. These are the experimental results. So here I used 5 data sets. So here I used the 5 data sets collected from the UCA repository, cylinder bands, and it is having the 540, the total objects are there, attributes 20 are the numerical and 20 are the what is. So good mixing of the attributes. I collected the data set and applied the one. So 11 outliers are detected in this data set. So next, the credit approval data set is having 690 and 6 numerical and 10 categorical attributes are there. So 35 outliers are detected in this one. The percentage of total is 5.09. The German data set is 1007 numerical and 14 are the categorical, outliers 5 and percentage 0. Australian data set is 690, total number of objects, 6 are the numerical, 9 are the categorical, 31 are the outliers, and 4.49 is the percentage. Hot data set is having the 303 objects are there. Out of the attributes, 5 attributes are numerical and 9 attributes are categorical. Okay, 7 outliers are found in this data set. So this is a bar graph for number of outliers. This is the performance of IQR, how it is calculated. Here, the accuracy is in case of credit approach 97.70, and accuracy of Australian is 98 and hot is 98 and highest is 99.16 is with the German data set. Similarly, the sensitivity is I got 100% for the Australian remaining 4 data set and 96.95 for German credit data set. So F1 score is 97.20 for the credit data set. Highest is again German data sets. So this algorithm is given the good performance for the German data set. Highest performance I got in all performance measures. So this is a bar graph for the performance of the IQR. So comparison with the existing algorithm. So it is given the good, better results with the existing model. These are the observations from the above table. The proposed approaches achieve the highest true positive rates in F-scores values across all the data sets. The proposed method achieves the ranges of accuracy of 98.376 average, and TPR is 97.16 average, and FPR is 2.64%, and F1 score is of 98.382. Overall, in terms of accuracy, TP rate, and F score, the proposed algorithm performs better than AOD, while the FPR achieves the both approaches are comparable. The proposed method reports the average of 99.39 TP rate. So true positive rate. This means that 0.61 outliers are misclassified as outliers by the proposed approach. So our approach is able to identify the outliers in an automatic fashion. This eliminate the practical usability. Its usability to effectively identify the outliers in the real-time applications. Coming to the conclusion, so this is in general outliers are very few in the number in every data set. So achieving accuracy has been difficult because of the rarity of the growth truth in the real world situations. Another challenge is finding the outliers in dynamic data set from dynamic data set. The huge scope of outlier detection. So new models and algorithms are needed to more reliable and detect outliers when the challenging the scenarios. Like outlier detection is in our IoT devices with the dynamic sensor data, the cost of the using the deep learning approaches to address issues with the outlier identification is high. Therefore, there is still need on the applications of deep learning algorithm methodology. Future research is required to understand how effectively and appropriate update the current models in order to discover the outlying trends. Future scope. Identification outliers falls under the imbalanced classification. Test the algorithms on data sets with a multi-class target values. So far I applied on only binary classification. I did okay. In futures I can apply this algorithm for multi-class classification. The test performance computationally efficiency of the algorithms are larger and dynamic data sets. There are two more directions. First one is influence of outliers and classification. Next, we can focus on performance metrics for outlier detections classification. So there is a accuracy. These are not sufficient. We need a new performance metrics for outlier detection. These are the references. 20 papers are collected and any queries. Thank you. Thank you, Manda.